My friend, this is our second video for sets, and we have looked at the types of sets, and also we looked at how we can differentiate between set A, set this one, set the types of sets, and so on. Today we are going to consider what we call sets and how we can represent these sets on a Venn diagrams. Remember, CBC just tests what we call the understanding of the subject. We need you just to get the concept such that you can attack any question when it comes on your way in an exam. Now, when it comes to what we call sets here, and for information, here we are having A and B. These are the sets, say, which is given to us, and we are having A is having members. They are like 4 members. Then we are having also B is having 5 members or 5 elements. Now, when you look at this one on a Venn diagram, this is a diagrammatic way of representing sets. They are sometimes called charts, but they are known as Venn diagram. Today, we are having 2 subsets. We can also draw the set which is having 3 or 4 subsets altogether. Yes, when the set is having more than 3 subsets there, we can also represent it on a Venn diagram. But let us begin elementarily with this one. Now, we are having regions where we always represent or write when we are dealing with these Venn diagrams. Now, when you look at this one, the members which are found here, are you seeing the members inside here? Here we write only members in A. Only. Then members here, we write only members in B or in set what? B. Then inside here, we write all of those members who are in A and what? And B. It means when you are given sets like these ones, what you always do, you just come and observe element per element. And you have to observe, is a 2 found in set B? Are we together? If it is not there, it qualifies to come here where I will write only A members. When it is found between inside A and B, when it is found here and here, it is written here in the intersection part. And this is the intersection what? Intersection part. And this one is the only members of B altogether. And for information, we are having the way how we write this one, and this one altogether. And also the way how we can write these members here. For information, we can write the number of those members in A. We write them like that up here. And also we can say these are the numbers of elements in B altogether. Then it is only A members. How do we write A only altogether? How do we write B only altogether? And how do we write A and B? I think all of us, we know here, we say these are members who are here. There will be numbers of those members found in A. Intersection what? Intersection B. Those members in A intersection B, they are always found here in between the 2 sets. When you say A, this B only, if at all we are having 2 subsets here, then now we are going to introduce a word, a complement. For your information, now a complement comes when they say A only, a complement. When you have to identify that when you remove all elements of A, what remains there is the members here. It means all members here, there will be number of a complement. Are you together? It means when you remove all the members of A, what remains there? Because a complement is like ng'oggyeko aba A abasigaddewo be baliwa. When you remove all members of A, the balance is only those members of B. Are we together? It means number of A complement is equal to number of B only. Are we together? That is very sensitive. And also when it comes to this number of A only, it means here is the number of B complement, because now these members of B complement ng'oggyeko ba members ba set B. What remains there? They are members of A only. Are we together? In sets, these are the terms we always use when we are dealing with the sets. You have to know A only is B complement. Are we together? Number of A only is the number of B complement. When you remove all members of B, what remains there is A only. And when you remove all members of A, what remains there is a number of B only. What intersects here is what we call the number of A intersection what? B. Are we together? Now we are proceeding with our feeding in all these values. Are we together? Now let us look at this diagram. Now we look at this one. We are going just to cancel one by one. Let me just use a red one. Now, is a 2 found here? Let us just look at this one. Is a 2 also inside here? Automatically, no. It means a 2 qualifies to be in only A. Are we together? Now we look at, is a 3 found down? Yes. There is a 3. It means a 3 comes in the intersection part. Are we together, members? Then we proceed with a 5. Is a 5 found in set B? Yes. It is also there. It is also included within that very set, intersection part. Then we have a 7. Is a 7 found in set B? It is a big no. It means the 7 qualifies to be in A or A only. Then now we come at this very point. The balance, it means they are only found in set what? In set B. We are having a 6. We are having a 12 and also a 15. Those are the members of set A and B, and that is how we represent it on a Venn diagrams. Now, here we are having something special. We are having something special. When you represent this one, and we have known that these members here, they are members of set A, and this one the members of set B. All of them, they are found within sets of B. All together. Now there is an important formula we are going to look at. Do you know? Now look at this one very critically. The number. Let us just use this space here. Hope you can at least identify. No, let us use this one. Do you know that when you look at the number of A union B means what? The number of A union B means these are the members found within the whole subset. When you get all the members when you look at, you add all members within that very subset, all the subsets, you get what you call a universal set. Are we together? A universal set takes all the members within those subsets. Are we together? Now, what is more interesting here? This one, to obtain the total number of members in A and B, all of them combined, is the same as getting the number of elements in set A. Then we add on. the number of elements in set B. Are we together? Then also we subtract the number of elements in set A intersection what? Intersection B. I need you to understand this, because when it comes to obtaining the union set, you'll be in a position to come up with this formula. You have to understand it. I need you to look at this one. Why is it here we are subtracting the number of A intersection B again? All together. Look here. When you look at the members here, we have said to get the total members within this very set, all of it, we come and we say it is written as number of A union B. But to get the total number of members in A, you add the whole of this one. Are we together? Then when you add on the whole of this set here also, it means the members within this intersection part, you have counted them twice. Are we together? That's why these members here, you have counted them when you are dealing with the number of elements in set A. But when you add on set B, it means you are repeating the members here. All together. Now, from this point here, you subtract the members which are here just to come up with the members in the union set. All together. All universal members, all universal elements, we don't repeat those intersection numbers. All together. The elements in the intersection, they always write them once in the union or in the universal set. That's why here we have subtracted this. All together. Yes, when it comes to this one, in summary, we have understood what a union is. We've got to know how we can represent this symbol, that this is the number of elements in set A, this is the number of elements in set B, and also we have seen what we call the complement of all members all together. And for information, to get the universal, when you need to represent these ones in the universal, sometimes remember when we draw our Venn diagram, say this is A and this is set B. Do you remember that one? Universal, sometimes we use this. And we say this is the number of the universal set altogether. Then this one will be the number of A, number of B. This is the intersection. This is A only. This is B only. Altogether, this is how we can say represent including the universal part altogether. Which means by the time you get away, we will have to understand this. That here is the number of B complement. This is number of A complement. Are you seeing that one? This one is the number of A intersection B, and here the members here is the members which are union, which are found inside here. Those are the union set. Or here we can say this is A only, and this one is B what? B only. That is the way how we can represent these sets on a Venn diagrams. Then in the next part, we are going to see how UNEB always sets this, how CBC is going to be handling these sets when you're having a question. We are going to do a UNEB question paper, which came in 2019, and it was question 2, which contained this. Those who are doing new curriculum, my friend, the knowledge remains the same. The same. You have to understand what this is all about. And when it comes to sets, I think the initial arrangement of sets here gives you at least a section A numbers. Those are the 4 marks or 6 marks, my friend. When it comes to sets, please join us in the next video for other examples concerning calculations. We apply the knowledge we have learned in these 2 videos and the link for the playlist is included within our channel altogether. Please subscribe to this channel for the latest videos. We may thank you for your subscription and for your time for this. Next video is all about examples on sets calculations. Thank you for watching.